Hi everybody, welcome back. Today we're going to be talking about simplifying radicals once again. And just like you did yesterday when you started simplifying radicals, we're going to list out a bunch of perfect squares. So probably the first 20 or so perfect squares that we learned in order to help us when we simplify the radicals on this page. So to start, remember a perfect square is when we take the same number, so for example 1, and we multiply it by itself. What do we get when we multiply 1 times 1? We get 1. So 1 is a perfect square because its factors are the same value, 1 and 1. 2 times 2 gives us 4. So 4 is a perfect square because its factors are the same number multiplied together. And just listing on, so 1, 4, let's see, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 17 squared is 289, 18 squared is 324, 19 squared is 361, whoops, and 20 squared is 400. Don't mind some of my numbers here. All right. Now, we understand it might be really tough for you to memorize these, especially when we get into the 16 squared, 17 squared, 18 squared, and 19 squared. So you have your calculator. Obviously, feel free to use it to help you get these perfect squares when you're simplifying radicals. So we're going to simplify the following radicals. Remember, we're looking for factors of these values where one of them is a perfect square. Now for 320, if I'm looking at my list above, I'm thinking in my head, okay, what two numbers multiply together to give me 320? One of those numbers being a perfect square. So we have a couple options here. Now use your list. Okay, we obviously want one of these values in our list above to be one of the factors that we're using. Now if I'm looking at 320, anything pretty much from like 225 on, and really even 169 is not going to be a factor of 320. So if I think of multiples of 169, 169 times 2 gives me 338. So that one's out too. 144 times 2 gives me 288. That one's out. So when we're thinking about factors of 320, really think about what numbers would potentially make sense in our list above. So I'm going to take a look. I'm going to work my way down a little bit. I know 121, 144, those guys are out. Same with 100. I'm going to start looking 81 and below. Now 81, multiples of 81, 8, 16, 24, 32, except we have that 1 at the end. So nope, we're not going to have a nice even factor here for 81. Let's take a look at 64. Can I take 320 and divide that by 64 and come out with a nice even number? Yes, I do. So if I take 64 times 5, I get 320. Now 64 is a perfect square. Remember, we're going to break this into a multiplication problem. So the square root of 320 is the same thing as saying the square root of 64 times the square root of 5. Okay? So now let's look at this and we'll say, what is the square root of 64? Well, the square root of 64 is 8. 64 is a perfect square. 8 times 8 gives us 64. The square root of 5, oh, that one's not so great. If we go to our calculator and find the square root of 5, we are going to have a very long decimal. The square root of 5 is an irrational number. So because that's the case, I am going to leave the square root of 5 as is, because we are writing each of these examples in simplest radical form, which means there most likely will be some type of radical in our final answer, and that is okay. We don't want decimals, or really long decimals, I should say, when it comes to our final answers. So in this case, for number 1, the only thing I have left to do is really take out that multiplication sign in the middle and write 8 root 5. So this is the square root of 320 in simplest radical form. If you were to type in the square root of 320 into your calculator, you would come up with the exact same value as if you typed in 8 times the square root of 5. So these are the exact same values, just written a little differently, written in simpler form. All right, so let's look at the square root of 343. So again, if I'm looking at my list here, I'm trying to figure out what could potentially be a factor of 343. So I'm getting down to, I know 100's not going to work. I know 121 is not going to work. 144. So those ones are they're a little too high. They're definitely not factors, or I should say they're, if I looked at 169 and 196 and I look at multiples of those numbers, I'm not getting to 343. So I'm going to go a little lower. Let's see. I'm going to try 64, although I don't think that's a good one either. Nope, it is not going to help me here. So I'm going to keep working my way down. Let's see, divided by 49. Oh, that gives me 7. Okay, so I'm going to use 49 and 7, because 49 times 7 gives me 343. So the square root of 49 times the square root of 7 is the same as saying the square root of 343. All right, so looking at the square root of 49, I get 7. That is a perfect square. 7 times 7 is 49. The square root of 7, that's one of those really scary decimals, one of those irrational numbers. So we are just going to leave that underneath the square root. We're not going to touch it. We're not going to write it as a decimal. We're going to leave it as a square root or radical. All right. And our last and final step here is to rewrite this without that little dot or multiplication in the middle. All right, moving on to number 3. Remember what this means. Negative 3 times the square root of 243. So now, breaking apart 243, I'm looking for factors of 243, one of them being one of those perfect squares from my list above. All right, so I know I can get rid of pretty much anything, 100 and above. Yep, I can definitely get rid of anything 100 and above. That's not going to work. If I look at 81 though, let's see, 81, 162, 243. So in my head I was just thinking multiples of 81. And multiples of 81 are 81, 162, 243. So you could do that in your head. You can obviously use your calculator. I could have gone to my calculator and said 243 divided by 81. Oh, yep, that gives me 3. Perfect. So in this case, I'm going to rewrite this as the square root of 81 times the square root of 3. Remember, when you're looking at your factors, one of your factors has to be a perfect square. The other one should not have any factors that are perfect squares. So if I look at 81 and 3, 81 is a perfect square. Notice how 3, the only factors of 3 are 1 and 3. Okay, so and neither of those, we're not really going to count 1, but neither of those are perfect squares that we're concerned with. So we know that we've picked the 2 correct factors. So looking at this, I am going to take the square root of 81, which is 9, because 9 times 9 is 81. The square root of 3 is irrational, so I'm going to leave that as the square root of 3. Now, anything outside of my square root, I am going to actually multiply out. So negative 3 times 9 gives me negative 27. but that square root of 3 stays underneath, or I should say, the square root of 3 stays on its own. Okay, we're not going to actually multiply that through. I don't want any decimals in my answer. We're going to leave the square root in the answer. All right, for number 4, 3/5 times the square root of 175. So looking at my list above, I'm thinking, all right, which one of these values could be a factor of 175? Well, definitely 25. We know that for sure. If I take 175 divided by 25, I get 7. So 25 times 7 is 175. Now looking at those two values, so 25, I'm going to make a little table here, times 7. 25 is a perfect square, 7 is not, and it doesn't have any factors that are perfect squares either. So think about numbers that multiply to 7, 1 and 7. That's it. So I know I have picked the correct values. I know I've picked the correct factors to simplify my square root. So 3/5 times, and I'm going to break 175 apart into the square root of 25 and the square root of 7. So 3/5 times 5 times root 7. Okay, so going ahead here, I'm going to turn 5 into a fraction by putting it over 1. Cross canceling here, my 5's cancel down to 1 each. So my final answer, 3 times 1 gives me 3, and that root 7 doesn't go anywhere because it is irrational. All right, moving on to number 5, -1/2 times the square root of 605. Looking at my list, we have a lot of potential values that could work here. Looking at my list, what could be a factor of 605? Okay, definitely not 400, not 361, not 324, not 289, or 256. Again, I'm just thinking of multiples of these numbers in my head, and I know none of them will reach 605 as one of their multiples. So no to 225. So again, if you can't do this in your head, use your calculator. 605 divided by 225. Does that give you something whole? No, it does not. Okay, so we are not looking to use 225. I'm going to try 605 divided by, let's try 121. Aha. So 605 divided by 121 gives me 5. So notice how 121 is a perfect square, 5 is not, and it doesn't have any factors that are perfect squares either. So we know we've picked the right factors here. So -1/2 times the square root of 121 times the square root of 5. Simplifying this, -1/2, the square root of 121 is 11. The square root of 5 is irrational, so we are just going to leave that as the square root of 5. -1/2 times 11, now you can write this two different ways. You can say -11 over 2 times root 5, or you can say -5.5 root 5. Either one of those is fine. And that's our final answer. All right, on to number 6. We have 0.3 times the square root of 288. That's what this means. All right, so factors of 288. Oh, that's easy. I can see that right away. I know that 288 divided by 2 gives me 144. So I'm going to use the perfect square of 144 because I know that 144 times 2 would give me 288. So I just broke that square root of 288 apart, and I rewrote it as the square root of 144 times the square root of 2. All right, so 0.3 times the square root of 144 is 12, and the square root of 2, that is irrational, so I'm going to leave that as square root of 2. 0.3 times 12 gives me 3.6, and then the root 2 stays as root 2. We're not going to touch that. All right, so that's just a little bit of review from yesterday. So now we're going to take it a step further, and we're going to write each of the following in simplest radical form. Notice how now we're going to talk about, or we're going to have some variables incorporated into our radicals here. So nothing to be worried about. So to simplify, the square root of 180 x to the 20th power y to the 6th power, we have to think about what is actually happening underneath the square root. So we are taking 180 times x to the 20th times y to the 6th. Okay, so if we had actual values for x and y, this would all be multiplication going on underneath that square root. So I'm just going to rewrite this for a second as the square root of 180 times the square root of x to the 20th times the square root of y to the 6th. So basically all I'm doing is I'm breaking apart each term that we are multiplying underneath that square root. So looking at the square root of 180 for a second, I want to think about how I can simplify that. So if I'm thinking about factors of 180, okay, so factors of 180, I want one of them to be a perfect square. If I look at my list above, let's see, I'm going to start with, not 49, let's start with 36. I think 36 is going to get us what we want. 180 divided by 36 is 5. Okay, and again, if you didn't know that off the top of your head, go ahead and work down through our list. 180 divided by, and start with the largest numbers, work your way down to the smallest. So 180 can actually be rewritten as the square root of 36 times the square root of 5. Okay, now I'm just going to rewrite x to the 20th times the square root of y to the 6th. Okay, so now let's start actually taking the square root of these values. So the square root of 36 is 6. The square root of 5 is irrational, so I'm going to leave this as a square root of 5. The square root of x to the 20th, so think about what we learned yesterday and actually the first day of notes in this section. So x to the 20th power, what are we multiplying together? Think about your monomial rules. That we're multiplying, we have a base of x and we need our exponents to add to 20. Now in order for them to be a perfect square, they have to be the same value. So what two numbers do we add together to give us 20 that are the same? 10. Okay, so this would be x to the 10th. Same thing with y to the 6th. Remember, we had to take y raised to a power times y raised to that exact same power to give us y to the 6th. So what did we add together to get 6? We added together y cubed. Another piece of advice here, as something that just might help you with these types of problems when you're dealing with variables, anytime you're taking the square root and your base is a variable, cut your exponent in half. That's going to be the value that you're looking for when you take like the square root of x to the 20th, you divided 20 in half to get 10. Y to the 6th, you divided 6 in half to get 3. So just as something if you want to kind of use that as you're moving forward. All right, so now I'm going to take everything that is not underneath the square root and I'm going to write that together outside on the left of the square root. So I'm going to take 6 and x to the 10th and y to the 3rd. When I write those as a multiplication problem, I would get 6x to the 10th, y to the 3rd, right? That's us kind of saying we're going to multiply all of these things together. Now the square root of 5 just stays square root of 5. I am not going to try and work that out. It's going to give me a very long decimal. All I am trying to do is simplify what I'm looking at, and I have done that right now. So this is what we would call simplest radical form for number 1. Okay, so continuing on with number 2, 44, a to the 64th power, b to the 12th. We're going to take the square root of that. All right, so starting out, I'm just going to break all of this apart for a second. So the square root of 44 times the square root of a to the 64th power times the square root of b to the 12th power. So simplifying the square root of 44, 11 times 4 gives me 44. So 4 is going to be the largest perfect square that's a factor of 44 here. So I can rewrite this as the square root of 4 times the square root of 11, and then a to the 64th power, square root b to the 12th. All right, so now actually taking the square root of these values, the square root of 4 is 2. Square root of 11 is nothing nice, so we're going to leave that as the square root of 11. The square root of a to the 64th power, remember, take 64, cut it in half. So a to the 32nd. B to the 12th, take 12, cut it in half. B to the 6th. Now everything that is not underneath a square root gets written first. 2, a to the 32nd power, b to the 6th, and then followed by that square root of 11. We do like to make sure that when we're writing variables, we are writing them in alphabetical order. So a followed by b, x followed by y. Okay, taking a look at number 3. All right, I'm going to start simplifying a little sooner this time around. So looking at the square root of 135, I'm trying to think of what are factors of 135, one of them being a perfect square. I go back up to my list, and as I'm looking at my list, I'm thinking 9 might be the value that works for me here. So 135 divided by 9 gives me 15. Now 15 is not a perfect square. It doesn't have any factors that are perfect squares. So I've got the 2 factors that I need to simplify the square root of 135. So the square root of 9 times the square root of 15. And again, I'm just breaking all this apart here. Okay. All right, so simplifying. Square root of 9 is 3. The square root of 15 is nothing super nice, so we're going to leave that as a square root of 15. The square root of m to the 44th power, cut 44 in half, m to the 22nd. The square root of n to the 64th power, cut 64 in half, you get 32. Take everything outside the outside the square root. Write those first. Make sure your variables are in alphabetical order with your square root at the end. And this is how we simplified the square root of 135, m to the 44th power, n to the 64th power. All right, on to number 4. Square root of 600, c to the 14th power, d to the 26th power, e to the 2nd. All right, so right away I know that 100 times 6 is 600. 100 is a perfect square, 6 is not. There are no factors of 6 that are perfect squares. So I can break the square root of 600 into square root of 100 times the square root of 6. Then I'm going to take c to the 14th power and put that underneath its own square root. Same with d to the 26th power and e to the 2nd. All right, simplifying all of this, the square root of 100 is 10. The square root of 6 is nothing nice. The square root of c to the 14th, cut it in half, 14 divided by 2 is 7. The square root of d to the 26th, cut it in half, we get 13. E to the 2nd, cut it in half, we get e to the 1st. Let's take everything outside of the square root, and let's put that, put that in front in alphabetical order, of course, with the square root of 6 at the end. So again, all we're doing is basically rewriting what we're originally given. All of these are exactly the same as what we were originally given. We're just trying to simplify any perfect squares that are located within, or I should say underneath, that original square root. All right, so looking at number 5, this is the same thing as saying negative 7 times, 384. 384. If I look at my list, what can I divide 384 by and get a nice round number? Okay, I'm going to try 64. So 384 divided by 64 gives me 6. Okay, so 64 times 6 is 384. 64 is a perfect square. 6 is not, and it doesn't have any factors that are perfect squares. So we're good to go. Okay, so I can rewrite this as the square root of 64 times the square root of 6 times the square root of x to the 34th power. All right, simplifying everything. Negative 7 times 8 times root 6, because it doesn't come out to something nice and round, And then the square root of x to the 34th power is going to be x. Take 34, cut it in half, and you get 17. All right, so combining what we have on the outside here, negative 8 times 7 is negative 56. X to the 17th, and then times root 6. There we go. All right, taking a look at number 6. We're just going to keep moving on here. 1/3 times, all right, factors of 63. That one's an easy one too. 9 times 7, where 9 is my perfect square. 7 is not, and it does not have any factors that are except for 1. And then we have times r to the 16th power. Okay, so simplifying here, the square root of 9 is 3. The square root of 7 is irrational, so I'm going to leave that as the square root of 7 because all we're doing is simplifying. And then r to the 16th power gives me r, and I'm going to take 16 and cut it in half to the 8th power. All right, so now when I go ahead and combine everything outside of the square root, 1/3 times 3 gives me 1. So I have 1 times r to the 8th. So we can just write r to the 8th. If you want to put 1r8, that is absolutely fine, followed by root 7. Okay. All right, onward and upward here. 2/3 times taking 108 and figuring out factors, one of them being a perfect square. Well, I know 36 times 3 gives me 108. So I'm going to rewrite this as the square root of 36 times the square root of 3 times y to the 58th power times the square root of z to the 82nd power. All right, taking the square roots where I can. Square root of 36 is 6. The square root of 3 is not great, so we're going to leave that as the square root of 3. The square root of y to the 58th power gives me y. Take 58, cut it in half, and I get 29. The square root of z to the 82nd power gives me z. 82 cut in half is 41. Combining anything on the outside of the square roots, 2/3 times 6. If I take 6 and I make it into a fraction here, 3 goes into 6 2 times, and 2 times 2 is 4. And then y to the 29th power, z to the 41st, and that square root of 3 at the end. So these next two I'm going to run through just a little quicker. You can take them slow and try them on your own. I just want, I want to at least show you the work. And then times q to the 6th. So square root of 49 is 7. Root 6. Q to the take 6, cut it in half, and you get 3. Combining everything on the outside, we get negative 28 q to the 3rd power root 6. Okay, and then last one for this page, negative 5/6 times, now this one's tricky because I know immediately for me I want to say 9 times 8, but here's the thing, 9 is not the largest perfect square, that's a factor of 72. 36 is, because you can take 36 times 2. So make sure when you guys are going through this, you are looking for the largest perfect square that is a factor. And in this case, 36 is larger than 9. All right, so the square root of 36 is 6. Square root of 2 is irrational, so we're going to leave it like that. And then the square root of x to the 100th power gives me x. 100 divided by 2 is 50. Okay. Cross canceling here, I'm left with negative 5x to the 50th power root 2. Okay. All right, so continuing with more on the back. Okay. All right, and again, I'm just going to go through and I'm going to pick out the factors that we're going to use. I'm just going to tell you them right away. If you want to take some time on your own, give it a whirl, and then come back and check your answers, you're more than welcome to do that. All right, so looking at the square root of 392, I can split this up into the square root of 196 times the square root of 2 times the square root of x to the 14th times the square root of y to the 52nd. Okay. And if I go ahead and simplify everything, I'm left with 14 x to the 7th, y to the 26th power, root 2. So sorry, I'm just going to go a little quicker on this part here, just because I don't want to take up too much of your time. So square root of 486, I can split that up into the square root of 81 times the square root of 6 times the square root of a to the 18th times the square root of b to the 22nd times the square root of c to the 72nd. And if I simplify all of this, I end up with 9 a to the 9th, b to the 11th, c to the 36th power, root 6. For number 12, we would get the square root of 9 times the square root of 6, that's the square root of 54 simplified, or I should say broken apart. And this is going to leave us with 3m to the 47th power, root 6, once it's all simplified. Number 13, the square root of 48, I can break apart into the square root of 16 times the square root of 3, and then the square root of y to the 76th power. When everything is simplified, we would get 40 y to the 38th power, square root 3. For number 14, negative 2.1 times, let's see, for 245, I can take the square root of 49 times the square root of 5, and then square root of x to the 70th. And again, when everything is all simplified here, we get negative 14.7 x to the 35th power, root 5. And last but not least, for number 15, 1/8. For the square root of 192, we're going to use the square root of 64 times the square root of 3. So we broke that apart. And then I'm going to try and squeeze this in here. And 38, square root of p, 56. And then our final answer would be m6, n19, p28, and then root 3. There we go. So go ahead and give those ones a try on your own, see if you can come up with the same thing that I got. All right, so looking at multiple choice questions. For number 16, what is the square root of 32 expressed in simplest radical form? Well, take a second, so don't get caught up in the actual answers just yet. Why don't you do your work first and then see if what you get is one of the answer options. So if I'm looking at the square root of 32, I know that the square root of 32 can be broken up into the square root of 16 times the square root of 2. Remember, you're pulling out the largest perfect square that's a factor. In this case, it is 16. 8 and 4 are also factors of 32, but 4 is not the largest perfect square. That is a factor of 32. So we're going to use 16. So the square root of 16 is 4. Square root of 2 is irrational. So the square root of 32 in simplest radical form is 4 root 2. So choice 2. For number 17, when 5 root 20 is written in simplest radical form, the result is k root 5. what is the value of k? So you're looking for that number on the outside of the square root once everything is simplified. Okay, so once again, just don't worry about your answer options right now. Let's actually work through the problem. Let's simplify this ourselves. So the square root of 20 can be broken up into the square root of 4 times the square root of 5, because 5 times 4 is 20, and 4 is a perfect square. So root 4 is 2, so 5 times 2 times root 5, because the square root of 5 is a very long decimal. And then simplifying everything that's on the outside of the square root, 5 times 2 gives us 10 root 5. So that k value is the number that's on the outside, so the number that's on the outside is 10. So once again, option 2. What is the square root of 72 expressed in simplest radical form? Again, don't look at the answer options just yet. Let's actually do this ourselves first. So the square root of 72, again, my mind immediately goes to 9 times 8, but guess what? 9 is not the largest perfect square. That's a factor of 72. But 36 is. Remember, you can take 36 times 2 and you get 72. So in this case, I can break apart 72 into 36 times 2. And the square root of 36 is 6 root 2. So answer choice 3. Number 19, what is 2 root 45 expressed in simplest radical form? Again, just as we've been doing with the rest, do it on your own first. See if your answer matches one of the options. So the square root of 45 can be broken apart into root 9 and root 5. Okay. Now what is the square root of 9? It's 3. The square root of 5 is a very long decimal, so we are going to leave this as the square root of 5. 2 times 3 gives us 6 root 5, which is answer choice 3. All right, approximate the square root of 79 and write the answer as a decimal to the nearest tenth. Okay, so we're going to go to our calculators and we're going to use that square root key. So remember, for the square root key, you hit second and you hit that little like caret up arrow thing that's located underneath the pi key on the left side. So it's in between pi and the x squared. Or I'm sorry, I apologize. You're going to hit the x squared key first. This is tomorrow stuff I'm already getting into. So go ahead and hit second x squared, my apologies, and then type in 79, close your parentheses. So the square root of 79 is 8.888194417. We're going to round to the nearest tenth. So when we're going to round to the nearest tenth, I'm going to look at the hundredths place, noticing that it is above 5. I'm going to take this and I'm going to round up to 8.9. So answer choice B. Let's do the same thing. We're going to estimate the square root of 18. So the square root of 18, again, second, x squared, 18, close the parentheses, gives us 4.242640687. Okay. Now we're going to round, it looks like we're rounding to 3 decimal places here. So I'm going to take a look at the 4th decimal place, so the 10,000ths place, to help me out. I see that it's a 6, which is above 5, so I'm going to take my thousandths place, which is a 2, and I'm going to round it up. So the square root of 18 is approximately 4.24. I'm going to round this up to 3. And that matches answer choice B as well. All right, so that's all we've got for today. Don't forget to do your review on quizzes. It's a radical review. So make sure you do that the next 2 days, and we will see you again on Friday.